Hello students, today we're going to go over lab Elec03 application of galvanometer, and we're going to go over a variety of applying galvanometer as ammeter, voltmeter, and ohmmeter. So a galvanometer is a simple apparatus that started all the multimeter technology. So first of all, it actually comprises with something very simple. Once you apply the current across this apparatus, so you would actually create a torsional force that would drag the needle across the scale, and you can correlate that as the current going through the galvanometer. Or if you know the resistance of the galvanometer, you can use the Ohm's law to calculate the voltage across the galvanometer. However, the galvanometer usually withstand the current up to only just 100 microampere, and allowing only just around like 50 millivolt at maximum current. So these things don't work really well as a voltmeter or ammeter, so it's gonna need some modification in order to for them to stand out as an actual like multimeter. So in this lab, you'll be using the RH, the rheostat, the adjustable resistor, a galvanometer, a standard resistor, a battery of 1.5 volts, and then a small adjustable resistor, and then your standard multimeter. So mostly we're going to be focusing on equipment number 3, the galvanometer. So usually the full-scale reading, IF, is going to be around like 50 microamps, and you can calculate the galvanometer resistance RM just by dividing the voltage across them with the current that you're reading, and then the full-scale voltage VM, which is the voltage that you can measure across the galvanometer, and then you can use all this information to calculate the galvanometer sensitivity. So once you know all the fundamentals about the galvanometer, you can actually use them as application as ammeter and the voltmeter. So for ammeter, since the galvanometer can take only up to 50 or 100 microamps, so then the current goes through here must be up to like whatever maximum current the galvanometer could take, in this case 50 microamps. So then you need a shunt resistance RS, which has to be very small compared to RM, and then this would steal most of the current. So if you add the two current, you would actually get the total current that you want to read from ammeter. And in this lab, we're going to modify the 50 microamp up to 50 milliamp as ammeter. So you're going to steal most of the current and do some calculations. On the other hand, if you want to use it as the voltmeter, you're going to have to connect it on top of an apparatus that would actually have a voltage. Again, since galvanometer can withstand very little voltage, up to like something 50 millivolts or something. So since you know that the voltage across this guy can't be up to 50 millivolts, you need some large resistance to steal most of the potential, acting as a potential divider, RV. So you're gonna need to calculate some RV and use that to actually adjust your galvanometer to be able to measure the voltage up to 1 volt when this thing can actually take up to like 50 millivolts or so. So first part, we're gonna study this current sensitivity of galvanometer. First of all, adjust your R to be large, 69,990 ohms, and then connect the whole circuit like this. So connect the battery to a rheostat, so battery goes to rheostat, and then the middle of the rheostat stays there, and then from rheostat connect it to an adjustable resistor, and then connect that to an ammeter. Set the ammeter to be able to read 50 microamps, so it has to be like the smallest reading on the multimeter, and then connect the multimeter to a galvanometer, and then galvanometer back to rheostat. So these two images are similar, and then you can actually adjust R. So keep adjusting R until the scale of this galvanometer deflect by 10 scale, 20 scale, 30 scale, 40 scale, and then maximum of 50 scale up here, and then record the IF that you can read from the ammeter here. Okay, that's supposed to be something around 50 microamps or so. And then on the second part, you're going to study the voltage sensitivity of the galvanometer. So again, you start from a high resistor, and then you use the voltmeter, but in this case, instead of using an ammeter as part of the current, this time you actually are measuring the voltage across the galvanometer. So the connection is similar, but instead of connecting this in parallel to in series to galvanometer, you're connecting voltmeter in parallel to galvanometer. So this thing is actually docking on top of that, and set the scale to be 0.1 dCV. Then adjust the R until the scale of this guy deflect by 10, 20, 30, 40, and 50 scale. So from that scale, you can actually convert it into current. And then since you know the voltage, you can calculate the resistance from dividing voltage with the current. Okay, so from there, you can actually get an estimation of Rm and then see how sensitive this thing is to the voltage that you apply. Then up next, we're going to modify the galvanometer as an ammeter. So first of all, you need to calculate RS, which is a very small resistance, a shunt resistance. So RS, you're going to be using this guy, which is a very small equipment here. The RS can be calculated as this equation. IF, you can calculate it from the first part, something around 50 microamps. And then I is the current that you want to use to read this whole apparatus as. So let's try to create an ammeter of maximum current of 50 milliamp. So use 50 milliamp in here and use the Rm that you know from the previous part. You can calculate RS and then adjust this guy to be close to the RS you calculate. It's supposed to be something very small. Again, RS is going to be your shunt resistance, so connect it in parallel to the galvanometer. So this thing is in parallel to galvanometer, and then use the adjustable R from here, and set the multimeter to 250 milliamp. So make sure you're able to read the 50 milliamp, and then adjust R right here to be here to be close to RS, and then read the current from ammeter. Compare the current from ammeter with the galvanometer. Then 2.2, building a voltmeter. So again, you need some resistance to steal the voltage from the galvanometer. Otherwise, the galvanometer is going to be overloaded. So calculate the RV from this equation using V as 1 volt. So we're going to amp up the VF of something in order of millivolts up to 1 volt. And IF is roughly 50 microamps. So you know these numbers from previous part. Calculate the RV using this equation, and then you connect the whole equipment in a similar fashion, except for the voltmeter is reading the voltage across the galvanometer, and the adjustable resistor, so right here. So one leg is going to be attached to the minus side of the galvanometer, the other one is going to be connected to the positive side of the resistor. So from here, you can adjust R directly to RV, make it as close as possible. It's going to be something large. And then connect the voltage, the voltmeter, and set it to 2.5 V. Adjust RH until the galvanometer reads full scale, and then read whatever voltage is reading on the multimeter. And you're supposed to get something close to 1. So if you can do this, then you have successfully changed the voltage threshold of the galvanometer from milliamps to from millivolts to 1 volt. Alright, last part, we're going to be using it as Ammeter, and this is the most complicated part in this lab. So first of all, connect everything in series. So this is a very simple circuit. So just galvanometer directly connected to the adjustable resistance, and then add it to a battery. Then call this contact A, and then again connect the positive part of the galvanometer to contact B, and then start with R of 20,000 ohm, and then adjust R until galvanometer reads full scale deflection once you connect the A and B together. So this is almost like a setting 0 of your ohm meter. So connecting these two together, you're supposed to get a full scale reading right away. So connect A and B together without any RX first, and then adjust R until G. The galvanometer reads maximum deflection, so something like 50 microamps here. Then read the deflection G as D. So this is 50 scale, so you can record that as 50. So that is your DF, and then you can connect it with Rx. So instead of having this guy up to df, it would drop to some scale, record that as d. So it should be something between 0 and 50. So then you can calculate the current by dividing d with df, and then multiply that by if, and then you could read the current. So once you know the current, you can calculate Rx, which is the unknown resistance that you connect onto it. Read the Rx and then compare it to the Rx that you can actually calculate from this. So since you know R, you know Rm from previous part, you can read volts. You know what voltage it is right here, right? The voltage is 1.5 volts, and then you can read the current from the deflection. So calculate Rx and then compare the Rx with the actual Rx that you put in. Then change Rx, then plot Rx versus D. Okay, that's it. Enjoy the lab. Thank you.